says that the diameter of a circular disc is 40 centimeters with a maximum error in measurement of 0.25 centimeters. Use differentials to estimate the maximum error in the calculated surface area. So it's a circular disc. The area of a circle is pi r squared. The way I worked this out on my key is I took the derivative with respect to the radius. And I got the change in A with respect to the radius would be 2 pi r. Then I cross multiplied by the dr. You got the possible change in the area is 2 times pi times the radius times the change in the radius. But then what I did is I went in here, okay, if the diameter is 40, then I said the radius would be 20. Here's where I might have a mistake. The change in the radius, if you've got a circle, right, that's the radius, but all the way across is the diameter. The change in the diameter could be 0.25. What you're out by could be 0.25. So what Casey's saying is, can we use the change in the radius if they don't tell us the change in the radius? Right, I did. I put the 0.25 in there. And let's see, 40 times 2.25, is that 100? No, 40 times 0.25 is only 10. So that'd be 10 pi. So I got 10 pi centimeters squared. I'm saying that's the most we could be off for the area. What I probably should have done, which might show that this was wrong.
So, I mean, really, if you think about it, like, the error is because of, measuring the instrument or whatever, so really it's...
Yeah, would it matter, like, if we said they measured it from here to here, or from here to here? So let's check this. What if we've got the area is pi times the radius squared? Well, we know the diameter is twice the radius. So if I divide both sides by 2, that means the radius is 1/2 the diameter. What if I come in here and I write this in terms of diameter? Then instead of r, I can put 1/2 d. And then square that. So if we square this, we'll get 1/4 d squared times pi. Or 1/4 pi d squared. Then we can take the derivative of this with respect to the diameter. So we get the change in the area with respect to the change in the diameter would be 2 times 1/4 is 1/2 pi times d. Cross multiply by the change in the diameter. We put in we got 1/2 times pi. The diameter was measured to be 40, and then the change in the diameter was 0.25. So let's see, 1/2 of 40 is 20, huh? And 20 times 0.25 is 5. We got 5 pi centimeters squared. So we doubled the error when we went with the radius as opposed to diameter.
When you did it with the radius, couldn't you just divide the change, because you put the change in the radius as 0.25? Wouldn't you just divide that by 2 to get the change, to make it the actual change in the radius?
And that's what Casey asked, and I said I wasn't sure. Let's try it, and you're absolutely right. We would have done this since the radius they're only measuring half of it. We said this was only off by 1/2. Then here the 2's would cancel. We get 20 times 0.25 would be 5, which would be the same thing. So if you're looking at my key online, they didn't have Sugar Shane to check that for me. So I had a mistake on that. So if they're talking about the diameter, you got to cut the error in the radius in half, or do it in terms of that.